Good day. So today we are going to explain how to solve an equation of the form sin x equal to c. So first thing to check if c is not in the interval minus 1, 1, the closed interval minus 1, 1. So we know that whatever x belongs to R, sin x is belongs to minus 1 and 1. Okay, so we write this way: sin x is more than or equal to -1, less than to 1. So if I want to solve the equation sin x equal to c, okay, so if this number c is not in the interval minus 1, 1, this equation would have no solution. Why? Because we cannot find any number in R such that the sign of it, the image of it by the function sign, is more than or less than -1. So this is the first thing to check. So you have to look at the number c itself. Okay, what is it? Okay. So for the first case, when c is not in the closed interval minus 1, 1, the equation has no solution and we have nothing to do. Now, the second case, if c belongs to the interval minus 1, 1, here the equation has solutions. So either we are solving in R or we are solving in some different intervals. So our set of resolution is R or some given interval. We would proceed different ways. So if we are solving in R, okay, so we have just to find, okay, so when solving in R, okay, so we have just to go and find C, find alpha such that sine alpha equal to C. So it depends on the number C. If you have some special values, yes or no. Okay, so once I get that alpha, then solving the equation sine x equal to C comes to solve the equation sine x equal to sine alpha. So here we are replacing the number C with the number sine alpha. So remember, sine alpha is also a number. Okay, then from here I use my property. So this comes to say that x equal to alpha plus multiple of 2 pi, we write 2k pi, or x equal to pi minus alpha, this is the rule, I'm applying the rule, plus a multiple of 2 pi such that my k is in z. So this is the set of solutions of the equation in R. Okay, so this is the set of solutions of my equation in R. So solving in R is quite straightforward for this simple equation. So we'll write that as conclusion. The set of solutions is as equal, I write alpha plus 2k pi, comma, pi minus alpha plus 2k pi, such that my k is easy. So now it depends what is alpha. If alpha is pi over 3 or something like that, you can replace and calculate pi minus alpha, which is simplified. So this is the general way how to solve when we are doing the job in R. It's quite straightforward. Now, when it comes to solving in some specific intervals, okay, let's say we want to solve our equation in same equation actually, but in the interval from A to B. Okay, let's be open or half open. It depends on whatever is the case. This is just an example here. So we would have two ways how to do it. So either we do it algebraically, so in the first step and the second step, we are going to do the same exact ways that we have done here. So to find all the solutions in R first, then we do the intersection between the set that we call here S0. Actually, S0 is this one here. This is the set S0 we are given here. Then do the intersection between S0 and I. How would it be easy, difficult? It depends. Then we give the final conclusion after the intersection. This is the first way. So here I'm showing an example using the first way. So let's say I want to solve sine x equal to half in this interval. So I know that half equal to sine of pi over 6. Okay, half. Okay, which is this. This is my c in the given method. Half equal to sine of pi over 6. So pi over 6 here is my alpha. Okay. So first we solve in R like we have done, like I have just showed before this. Then we get the set of solutions in R. So this is S0 set of solutions in R. Then how to find the intersection between S0 and my interval R. If I do it algebraically, this is the first method, it's going to take quite a time to find. It's not too long, but it's quite, I would say, heavy to do. Okay, time consuming. So this would be an example how to do it. So I have to look at my set S0, how it is defined, what is it, to understand it. So S0 intersection I is going to be going to say that if X belongs to S0 intersection I, this comes to say that X belongs to S0 intersection the union of these two sets. Then I use a property. We have the property that A intersection B union C, okay, this is equal to A intersection B union A intersection C. I use this property right here for this step. Then for each subset, I will just go sub here. First subset, we'll just go to the job to find my possible values. For the second subset here, I will just go do the same job here to find my values. Then at the end, I will just give my final conclusion. I find my final set, and I give my final conclusion. So this is the first way how to do it. So here I'm finding algebraically all the possible answers. The second method, okay, we are going to, instead of doing algebraically, we are going to use the unit circle. So in the first method, to find alpha such that sine alpha equal to c, when using the unit circle, after drawing the unit circle, when we draw the line of equation y equal to c and find the intersection point between this line and that equation, at that moment, we are going to find some special values if they are well known. Okay. When we find all the associated values at that moment, we are doing this job. Okay, we are finding S0 actually. Then to do the intersection, so instead of doing it algebraically, to do the intersection, step 3 here, instead of doing it algebraically, we are going to make use of the unit circle to find all the possible values straightforward. And of course, at the end, we should give our final conclusion as well. So for the same example here, this is how it's done. Okay. So we draw the unit circles. So here I'm drawing it. So I'll do the steps here, right, one by one. So to draw the unit circle, okay. So my circle here wouldn't be that nice. I could draw myself one before. Okay. So I draw my unit circle first. Then I draw the line of equation y equal to half. So this is 1 unit here. This is half unit. I draw the line of equation y equal to half. Okay, this is the line of equation y equal to half, let's say. So my drawing, hand drawing is not that nice. Then I find the point of intersection between this line and the unit circle. So I know that this point, we associate to it the value of pi over 6, and to this point, we associate to it the principal measure, which is 5 pi over 6. So, okay, so here I'm doing the step 4, right? Okay, so what are all the possible measure, associated values here? So we have to just add plus k pi, right? It's plus 2k pi plus 2k pi here. So we have all the solutions in on. After that, we are going to find the points corresponding to the edge point of my interval, negative 5 pi, 5 pi. So we know that to this point here, we associate the value negative 5 pi. To the same point, we associate the value negative pi. So it means when we do the reading of our solution to use the circle, we have to start with this point and end at the same point. Now, the idea is we have to look to the length of our interval. So I have negative pi minus 5 pi. So it's b minus a. Okay. So it gives me 4 pi, which is 2 times 2 pi. So it means that we are going to do 2 laps. We start from this point. I do 1 lap. I do a second lap. Then I stop. Okay. This is step number 6. So we start the image point of negative 5, then we go into the positive direction. So when we do our laps, we go always into the positive direction. Then when I do the start to warp in, I do the reading. So I start from negative 5 pi, I do the warp in. So here, this is negative 4 pi. So this distance here is how much? Is pi over 6. So I'm having negative 4 pi plus, if I go to the positive direction, it's plus pi over 6. So the first value is negative 5 pi plus pi, we go to the positive direction, plus pi over 6. So this is the first full number. Okay. Then I carry on. So I have negative 5 pi plus pi. Remember, this is negative 4 pi plus 5 pi over 6. This is my second value. Then I keep. So I reach my point. I have done 1 lap. I carry on. Now the value here is negative 3 pi. Okay, so plus pi. So it's negative 3 pi plus pi plus pi over 6. Negative 3 pi plus pi plus 5 pi over 6. Then I reach. So after doing the reading here, I reach the point again. This is negative pi. Then I should stop. I must stop. Then the solutions that I have at hand, I have how many? 1, 2, 3, 4. Okay. So I should simplify these numbers, of course. Okay. So when doing the job, this method, we don't need to write all these details actually. So this is what we expect from our students to write, to show for us. So we expect from you to do the job. It means, well, you draw the unit circle, you draw the line of equation y equal to half. Okay, you find the points A and B. You find a value associated with each of these points. Okay, you find the points corresponding to A and B, the edges of the interval we are solving in. Okay, then you do the reading, you do everything, and you simplify your numbers straightforward. This is what we expect from a student to do when he or she is using the unit circle to solve some easy equation like this one. Okay, so it should be that the second method or the second way is much more faster and much more easier to do, to handle any question. But the most important thing is that the student should be able to do this job. The student must be able to locate a point corresponding to any given value. If I cannot find the point corresponding to the value A or B, okay, then I could never do the job. Okay, so basic things are first. Okay, so that's all. So to solve an equation of the form sine x equal to c, such that c is in R, we have to check first the value of c. Is it in minus 1, 1? If it's not, then there is no solution to that equation. Whatever is the set of solution. If c is between minus 1 and 1, so solving in R is quite easy. Solving in some given interval, it might be challenging if we do it algebraically. Okay, but if we use the unit circle, we would be doing the same thing actually, but in much more easier way. Okay, so that's all for this video. Thank you for listening.